This video shows how to perform an impact test via GFAI Tech Wave Hit and Prosig DATS tetrad. The first step is to connect the wave hit to the tetrad via Ethernet. Our setup here consists of test beam, tetrad, wave hit, and wave hit remote control. Here are our parameters. Test structure, metal bar. Measurement points, 6. Accelerometer used, uniaxial. Software, Prosig DATS hits, modal and structural animation. Let's launch wave hit. We will need to create communication between wave hit and our laptop. The next step is to choose a hammer tip. Then we set our impact force. Clicking this will automatically adjust our impact point and calibrating force. Let's now review our impact force in the wave hit software. The next step is to launch DATS hits. Load an existing geometry if available. Let's set up our DATS hits. Our test type is set to roving response. Number of response directions and setup components is 1. We will set all of our components to have a response position. Our impact direction parameter will be at Z direction. All of our response direction parameters will be set at Z direction. Let's set up our measurement channels. We also ensure that our node name is correct. Let's check our setup to ensure that it is valid. We move on to the test setup. Our green Start Pretest button is flashing, so we click it. This will auto-adjust gain and trigger level. We manually trigger the wave hit. Then we auto-adjust the response window. We stop the window test and move on to data capture. Again, we can see that the green Start button is flashing. This indicates that we can start our capture. Here, we can see a few things. Our excitation signal, frequency response function, response signal and coherence. Now it's time to move the accelerometer to the next measurement location. Then, we repeat the impacts for all measurement positions. We review the results and auto-picking peaks. Then, we calculate the damping factor. We load our modal analysis software. We then review all our measured FRFs. We choose a frequency bands for analysis. Then, on the Analysis tab, we choose our method options. In this instance, the half-power method to calculate our results. We start the DATS structural animation editor. We either have the option to create new or open an existing model. We create our geometry. We have the option to pan, zoom and rotate to enable a better view. Once we're happy with the layout, we can link our data with the geometry. Let's save our model geometry with the associated FRF data. When we have successfully saved, we load our structural animation application. Let's load our geometry with the FRFs. We review the mode shapes and adjust the animation speed and gain amplitude when necessary. Thank you for watching this demonstration.